Hello Science Today viewers. Today we have an interesting topic for you: imaginary numbers. Imaginary numbers are not just some abstract concepts of mathematics. They actually have a real physical meaning. According to a recent study, imaginary numbers are not just a tool used in quantum mechanics, but actually carry real information about quantum states. Before we dive into the study, let's have a quick refresher on imaginary numbers. Imaginary numbers are the square roots of negative numbers and are denoted by the symbol I. They were thought to have no real-life analogies until now. Real numbers are clearly observable in the real world. But imaginary numbers were only seen as mathematical artifacts until recently. The study was conducted by a team led by Alexander Streltsov of the University of Warsaw in Poland, and Kang-Da Wu of the University of Science and Technology of China in Hefei. They wanted to find out whether imaginary numbers are just mathematical tools, or whether they represent something real about quantum states. To do so, they used a mathematical framework to determine if imaginary numbers are a resource in quantum theory. In quantum theory, a resource is a property that enables new actions that would otherwise be impossible. The team's calculations suggested that imaginary numbers are indeed a resource. But the next step was to check whether this math works in the real world. To test this, the researchers set up an optics experiment where entangled photons were sent to two receivers, Alice and Bob. Their goal was to determine the quantum states of the photons. They could perform local measurements on their own photons and then compare the measurements, which would allow Alice and Bob to calculate their probability of guessing the correct state for the opposite photon. For some pairs of quantum states, the researchers found that Alice and Bob could guess the states with 100% accuracy, but only if they were allowed to use imaginary numbers in their local measurements. When they were forbidden from using imaginary numbers, it became impossible to accurately tell the two states apart. This experiment found the same thing as the math. The loss of complex numbers equaled the loss of real information about a quantum system. The information these complex numbers carry isn't related to a simple physical property, like the spin of an electron, but rather to the ability to extract information from a particle where the particle is located without considering interactions with other particles at a distance. This study has significant implications for the world of quantum computing. The information carried by imaginary numbers might help explain the underlying reasons why quantum computing allows for actions that traditional computing doesn't. The researchers plan to expand their search for other situations in quantum theory, where imaginary numbers might be a quantum resource. So, there you have it. Imaginary numbers are not just abstract concepts of mathematics. They are a real physical entity that has an impact on quantum mechanics. This research is important both from a foundational point of view and as a way of understanding how we can better harness quantum resources and how the quantum world works. That's all for today's Science Today viewers. Don't forget to like, share, and subscribe to our channel for more interesting and informative videos like this. Thank you for watching.